In this video, we'll be going over invert binary tree. So given the root of a binary tree, invert the tree and return its roots. Let's go over the thought process. So for each of the node x, we will first need to invert its left and right subtrees. Now, how can we invert the subtree that is rooted at x? We can just swap the children's subtrees. Now let's go over the pseudocode. So we're going to implement the recursive approach. Now what parameters do we need? We need node, the current node, or we can just say roots. The current roots of the subtree we are inverting. And now what's the base case? If roots is equal to null, this means we do not need to invert this node or the subtree. We can just return roots, or we can just return null. Then each of the recursive call, we're going to recursively invert the left subtree. And then we're going to recursively invert the right subtree. Now, in order to invert the subtree at the current roots, we need to swap the children's subtrees. I want to set root.right to left, and then set roots.left to right. Then we can return roots. Now let's go over the time and space complexity. For the time complexity, we get O of n, where n is the number of nodes. We visit each node once. And our space complexity, we get O of h, where h is the height of the tree. This is our recursive call stack memory. Now let's go over the code. Now let's first go over we're going to implement our recursive approach. Let's first go over the base case. So if roots is equal to null, there's no subtree to invert, we can just return null. Now we'll first invert the left subtree. Then we're going to recursively invert the right subtree. Now in order to invert the current subtree, we need to swap the children nodes or the children's subtree. Then we can return the roots. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.